Other thoughts or other first appearances or evidences of the Earth being spherical was could be thought of all the way back in, I think, like around, what was it, like 300 BC, when Aristotle was there. When was Aristotle there? About 300, 350
Yeah,
BC,
I think
right?
so.
And Aristotle, so there was, I believe it was Pythagoras. I'm pretty sure it was Pythagoras who first came up with the idea that the Earth is in fact a sphere, or is like round, right? Because no one really, I guess, cared or even thought about that, but at that time. But then Pythagoras was like, hey, it's round. But
Hmm.
he gave no evidence. He simply said, because of, I think it was something to do with, religious beliefs and something like that, that tied into the fact that the earth had to have been round. But
Hmm.
then, hundreds of years later, because I think Pythagoras was like 500 BC. So, like, this is like 150, 200 years later, when Aristotle shows up, he has evidence, or at least kind of like physical evidence, that the earth simply cannot be flat. One major point was constellations, stars in the sky. Like, in one place, you see different constellations in different locations
Hmm.
than on another place on Earth. And he did this, I believe he was in Egypt when he was doing this. And I think he just went to different places and he saw different constellations and he
Hmm.
came up with this conclusion that it simply can't be flat. Right? Another very famous one is the ship. Like when oh, sorry, you want to say something?
Oh yeah, I just wanted to allude to
Yeah, because I know you have a
our
star pointer.
episode.
Yeah.
Yeah, our episode on called QED, where we talk about proofs real quick. I just wanted to say, like, using the proof technique, right? The if then statement, right? So I'll assume one thing and prove that a contradiction and say, well, therefore it's not true. Okay, so let's assume the Earth is flat, right? Then at any point on the Earth, if you looked up at the sky, very distant objects would be like relatively in the same place, right? So one constellation that if you're facing north
Mm-hmm.
on the flat Earth, you look up, you'd be able to see some constellation. If you're anywhere else on that Earth facing north, you would be able to see that constellation above you, right?
Exactly.
But this is another experiment you could do right now. If you're in the northern hemisphere, you can see the North Star. You can look at it with your eyes and say, oh, okay, well, that's the North Star. You can then take a plane or a boat. You can go down to the southern hemisphere and you'll see that you can't see that star. If the Earth was flat, right, the North Star would always be above the flat Earth, no
True.
matter what.
True.
Unless you're arguing that the flat Earth rotates. Or, anyways,
Ah.
that's not the point. The point is that once you go to the southern hemisphere, the curvature of the Earth, right, makes it such that the Earth is in the way of the star that you're trying to look at. And this works, of course, with any other star,
Mm-hmm.
right? When you're
Any
you see
constellation
it.
too.
Yeah, and this also doesn't work, proving again that the Earth is spherical. This doesn't work for stars that are aligned with the celestial equator, which is just if you were to project a ball around the Earth, that like projection of all the stars is like the celestial sphere, and the celestial equator is just a slice from the equator of the Earth. This point that I just said doesn't work with the celestial equator because as the Earth rotates, you're always getting like a panned view of every single star that is along that point, right? So if you're
Mm-hmm.
on the equator and you look up above you, you see a star. 12 hours later, you're going to see a star that's on the other side, and then 12 hours later, you're going to see that same star again,
Yeah.
no matter where on the equator you are. Okay, and this is my last point. I'll let you continue after
Yeah.
this. It also turns out that when the Earth rotates around the sun is going to be in the view of other stars that are behind it, right? And so if you're at some point in the Earth's orbit, you you pretend the sun isn't there, but you look towards the sun and you see a constellation on the background. And then 12 hours later, when you face the other way, you'll see that there is a different constellation. Let's say constellation 2. The first one is constellation 1. Now, 6 months later, when you're going to be on the other side of the sun, you can look at constellation 1 that is going to be in the nighttime, and then 12 hours later, you won't be able to see constellation 2 because the sun is going to be in the way. This is just another experiment that you can do on your own.
I mean, you gotta wait for 6 months though.
Yeah,
Like-
you gotta wait, but it's still something you could do.
So those are really good points on, the starry sky and how Aristotle kind of thought about or concluded that, the Earth just can't be flat using stars, because it was it was seemingly obvious to him, but, had to be explained. So the other idea that I was talking about was how ships appear from the horizon, right? Like they don't simply come up, like, right? It comes
Yeah.
up slowly. It looks as if it's almost emerging from the water, right? Like in this case, or if it's like leaving, it looks as if it's kind of like slowing down or like kind of getting smaller as time goes on. It doesn't simply disappear, right? And that also right there can be a very obvious fact to why it can't be flat, right? Or why it has to kind of be round, because a round Earth supports the idea that, the hull disappears first, the hull of the ship disappears first, and then the sail disappears absolutely last because it's the highest peak, right? So he thought of this all the way in 350 BC. So this guy knew things that people don't know in 2020. It's kind of sad. But